Hello everyone, how are you all doing? I hope you all are doing good. In today's video, we are going to continue a new topic from chapter Acids, Bases and Salt. Also, this will be the last topic we will be taking in this chapter. Very important topic, that is water of crystallization. Now, we know that on heating, the crystalline substance, that is blue vitriol we are talking about here, that is copper sulfate, it breaks down to form a colorless powder, okay, and water comes out, right? When you do the following activity, what you do is you take a salt, that is copper sulfate, which is blue in color, and heat that in a test tube. So once you give heat to copper sulfate, you will see that drops of water stick onto the test tube and the blue colored powder turns white. Now the water which you saw, which came out when you heated copper sulfate, is nothing but water of crystallization, because when copper sulfate was blue in color, it had those water molecules within the structure of copper sulfate, because that structure was crystalline in nature, right? Now on adding water to the white powder, a solution was formed which had the same color as the solution in the first test tube. Now from this we come to know that no chemical change has occurred in the crystals of blue vitriol due to heating, whereas on losing water molecules, right, there happens a breaking down of the crystal structure and it loses its blue color, and it will regain its blue color on adding the water, okay. So losing blue color and gaining blue color is just a physical change, it's not a chemical change. Followed, students? So you can see the reaction CuSO4 dot 5H2O means one molecule of CuSO4 has 5 molecules of water, giving its crystalline structure. Followed, so once you give heat to it, it will lead to the removal of 5 molecules of water, and CuSO4 will remain as it is. Got it? So now we know that ionic compounds are crystalline in nature. These crystals are formed as a result of definite arrangement of atoms. In the crystal of some compound, water molecules are also included in this arrangement, okay, as we saw in the copper sulfate's example, correct? That is the water of crystallization. Now this water of crystallization is present in a definite proportion of the chemical formula of the compound. Now it is indicated in the chemical formula as shown below. First is CuSO4 dot 5H2O. Then if you see ferrous sulfate, which is also called as green vitriol, FeSO4 dot 7H2O. So what is this dot? Is the number of water molecules which are required to give crystalline structure to that particular molecule. Followed? Crystalline substances contain water of crystallization. The molecules of water of crystallization are part of the internal arrangement of the crystal. On heating or just by keeping, the water of crystallization is lost and the crystalline shape of that part is lost too. Followed? Now next topic, that is ionic compounds and electrical conductivity. The bulb glows only when electric current passes through it, and this can happen only when the electric circuit is complete. Followed? So what we are doing here is that we have taken a solution of sodium chloride and we have dipped 2 electrodes here. See, this is the solution of sodium chloride and these are the 2 electrodes. One connected to the negative terminal of the battery and other one connected to the positive terminal of the battery. Followed? So in a beaker you have taken this solution and you have put bare electric wires there, right? Now there is a switch here So once the circuit is complete, once you switch it on, the circuit will be complete and the bulb will glow. This bulb will glow. Followed? So the circuit will be formed when the aqueous solutions of NaCl, CuSO4, all these ionic compounds are formed. Correct? It means that these solutions are conductors of electricity. Right? So electrons conduct electricity through electrical wires and ions conduct electricity through a liquid or a solution. Now, electrons leave the battery at the negative terminal, complete the electric circuit and enter the battery at the positive terminal. Followed? When there is a liquid or a solution in the circuit, two rods, wires or plates are immersed in it. These are called as electrodes. See here. See here, to bear electric wire. So these becomes electrode. Right? Electrodes are usually made of a conducting solid, any metal. The electrode connected to the negative terminal of a battery by means of a conducting wire is called as a cathode. Okay, so that becomes negative terminal, and the electrode connected to the positive terminal of a battery is called as an anode. So this is your cathode, this is your anode. Okay. Why does the electric circuit get completed on immersing the electrodes in certain liquids or solutions? So in order to understand this, let us look more clearly at the solutions in the above activity, which were found to be electrical conductors. Okay. Now see, we will see how the electricity will be conducted. Right. Now few aqueous solutions like NaCl, CuSO4, they are conducting electricity because they can form ions. So these aqueous solutions, all of them, whether it is H2SO4, CuSO4 or NaCl or NaOH, they can form ions, that is cations and anions. That is why the dissociation of these ions leads to electrical conductivity. So a characteristic of the liquid state will be its mobility of particles, and due to this mobility means they can move. The positively charged cations in the solution are attracted towards the negative electrode, that is cathode. Okay. So cations move towards cathode. So ions which move towards cathode are called as cations, and the negatively charged ions that is anions, they move towards anode. So ions which move towards anode are called as anions. Followed? And because of the movement of these ions in the solution, they are able to conduct electricity. Followed? The next topic is electrolysis. Lysis means to break down, and electro means electricity or electric current. So breaking down of molecules when you pass electricity is called as electrolysis. For example, sorry. Now, if you see in this particular activity, you will see that copper has got deposited on the portion of the cathode. Right? Now, why did this happen? Because when you start electric current, the cations will flow or move towards cathode, and the negatively charged ions will move towards positively charged electron. Right? That is why a deposit of the copper will appear on the cathode. Followed? Whereas sulfate will move towards the negatively charged, that is anode. Now, even though the copper ions in the solution were used up in this manner, the color of the solution will remain the same, because while electric current was on, electrons were removed from the copper atoms of the anode, and sent to the battery through the electric wires. So the copper ions formed in this manner entered the solution, and in this way deposition of the solute in the solution took place due to the electric current, and this is called as electrolysis. Now there are two parts basically. One is cathode reaction, another one is anode reaction. So I hope it is clear to you. See what happens with copper. At the cathode, 2 electrons are added to copper ion. So it becomes copper atom, that is solid. Okay. Now at anode, what will happen to this copper? It will again become ion and 2 electrons will be given off. So this leads to the conduction of electricity. Continuously, what is electricity? Movement of electrons or flow of electrons. So electrons are constantly moving. That is how the electricity is generated. Followed. Now just go through this slide, that it is very necessary for the liquid or solution to have a large number of dissociated ions for electrolysis to take place. Therefore, substances which undergo dissociation to great extent in the liquid state or a solution are called as electrolytes. Salts, strong acids and strong bases are all electrolytes because the solutions have high electrical conductivity. Okay. An assembly that consists of a container, electrolyte and the electrodes dipped in it is called as electrolytic cell. What do we need for this? One container wherein you have electrolyte, that is your solution, and electrodes which is dipped in it is called as electrolytic cell. Followed. Now if pure water is used in an electrolytic cell, current will not flow even on putting the switch on, because pure water is a bad conductor of electricity, right? Because the concentration of H plus and OH minus will be very low. However, if you mix a small amount of salt or acid or base to it, it will conduct the electricity. Followed. So electrolysis of water. Now once you are doing electrolysis of water, what will happen at cathode? The water will be given the electrons to it, so it will become H2. See, H2 will remain as it is. See, because it is written 2H2, right? So there are total 4 hydrogen. 2 into 2. 4 hydrogen, right? So 2 hydrogen is here. Then 2 OH means 2 O and 2 H. Correct? Now this negative charge is because of these 2 electrons. Followed, students? So the equation is balanced. H2 plus 2 OH minus. Same is with anode also. So scientists have shown that hydrogen gas is formed near the cathode. Okay. Now cathode is positive or negative? See, cations are positive, so cathode will be negative. Anions are negative, so anode will be positive. Followed. So this reaction will take place at cathode and this will take place at anode. So at anode, what will happen? Oxygen gas will be there, and at cathode hydrogen gas will be there. See here, hydrogen and here oxygen. Thank you so much, students. Now I hope all the topics of acids, bases and salts are clear to you. Please learn all the reactions well. Okay. Thank you so much for watching the video.